AWS offers over 200 services, but Lambda continues to stand out, and for several reasons. In today's video, we'll cover what exactly Lambda is, how it works, some use cases, some benefits, some limitations, and a whole lot more. So, without further ado, let's get started. What is AWS Lambda? In short, AWS Lambda is the event-based serverless computing service for the AWS platform. Event-driven functions are compute events that happen automatically in response to various inputs known as triggers. This is sometimes called functions as a service, or FaaS for short. Through serverless computing, Lambda lets developers write and execute code without worrying about administrative tasks. Those tasks can often include booking server resources from cloud providers. It could be maintaining servers in optimal condition. It can include scaling RAM, CPU, and memory resources up and down manually. It could also include managing the underlying operating system, or even patching security issues. AWS takes care of these tasks on your developer's behalf. That way they can focus on writing code that's going to ensure your customers have a smooth service delivery. Think of Lambda as a fully managed service that you can use to develop and run cloud-based operations fast and cost-effectively, by not needing to buy, maintain, and replace all the hardware required. Not to mention the time and money you'd need to hire experienced talent to do all the maintenance work involved. A big reason why Lambda is so cost efficient is that it takes advantage of serverless architecture to reduce wasted cloud spend. So that takes us to our next question. Is AWS Lambda serverless computing? In short, no. Rather, AWS Lambda is an essential component of serverless technology for AWS customers. And here's how. You need a stack of several components to build an application on serverless architecture. One common architecture is the LAMP stack, which requires several things: Linux operating system, Apache HTTP server, MySQL relational database management, and PHP programming language. Another more specific stack for a web application would look like this: database service, HTTP gateway service, and computing service. For people already using AWS, Lambda acts as the computing service in that stack. But that's not why serverless computing can be a cost-efficient technology for running your operations in the cloud. There are two main benefits built into a serverless architecture. The first of those are the pay-per-request pricing model. With this model, you only pay for the requests that Lambda has served and the time it took AWS to serve those requests. So before you compute request, you do not need to pay a cent, unlike other architectures that cost money by running continuously without actually doing anything for you. The second of those benefits is auto-scaling, which means that this service scales up and down based on demand. It can increase compute resources such as CPU, RAM, and memory when demand increases, but it shuts some of those down when you have little to no activity going on inside of those servers. It can automatically scale from 0 to infinity, back to 0 again when your system is idle. Here's a simple example of automatic scaling in serverless technology. Suppose you're an insurance company, and you're looking to enjoy the advantages of serverless technology. Your computing requirements are going to scale up in the case of a natural disaster, an approaching policy renewal deadline, or when you're running some sort of discount or promotion. It's during such times when potentially millions of people would search and log into your insurance company's website to take covers against losses, to make claims, or to sign up to redeem that discount. After the incident or the promotion, you would notice fewer people would be logging into your website, and that your server's RAM, CPU, and memory usage are all going to be reduced with the reduction in server activity. All of this would happen inside of your organization servers with no human intervention. Whichever the case, AWS would charge you only as much or as little computing power as you use. This is how the pay-as-you-go usage-based pricing model would work for serverless services. You don't need to book excess server resources like IT departments used to do in the hopes that the extra capacity would handle any unforeseen spikes in activity. You also don't pay for provision capacity that you don't use. AWS has an option where you can provision capacity via Amazon EC2. Combine the auto-scaling feature with not needing to buy hardware or maintain it, and you'll see why Lambda serverless architecture can be so appealing from a cost perspective. So how does AWS Lambda work exactly? Well, Lambda offers a powerful platform for developers to create and run complex cloud-based applications. It also integrates with AWS services seamlessly, so you have all the options you need to create large, secure, flexible, and cost-efficient applications. Lambda is unique because it automatically runs your code in response to multiple events from various sources within or outside the AWS ecosystem. And this is important because this is how you trigger Lambda functions, which respond by doing what you set them up to do without scaling limitations. So what is a Lambda function in AWS? A Lambda function is the code you run in AWS Lambda. And while you don't need to, be sure to write code in a stateless style. That means writing code in a way that assumes that there's no affinity to the underlying AWS Lambda infrastructure. You can create, call, and manage Lambda functions using these 5 interfaces: AWS Management Console, AWS CloudFormation, AWS Serverless Application Models, AWS SDKs, and AWS Command Line Interface. You might be wondering, why must you use stateless code for AWS Lambda? AWS Lambda only allows you to generate as many function copies as the rate in which events are coming in. That improves scalability and performance while keeping costs reasonably low. However, Lambda will let you access stateful data when you call on other internet available services, such as Amazon DynamoDB and Amazon S3. Next, let's look at what's in a Lambda function. AWS Lambda functions into independent containers that you use in a serverless application model for your code. The Lambda function is usually a container because it comprises of configuration information that relates to that function. That information includes the function name and description, resource requirements, and entry point. Here's an image to help you better visualize what we're describing, and feel free to pause the video if you need to. So then what triggers AWS Lambda functions? As mentioned earlier, many event sources can trigger Lambda functions. For example, you can trigger a Lambda function by updating tables in Amazon DynamoDB, changing an object in Amazon S3, parsing HTTP requests through Amazon API Gateway, or streaming data through serverless processing with Amazon Kinesis. More Lambda function triggers include CloudFront, SQS, Alexa Smart Home, SNS, AWS IoT, CloudWatch events and logs, and Application Load Balancer. Another important question many people ask is, what programming languages does AWS Lambda support? And AWS Lambda supports the following languages natively. There's Node.js, Python, Go runtimes, C# runtimes, Ruby 2.7, Java 8, and custom runtimes. It's also worth noting that AWS provides a runtime API that you can use to write code in additional languages. AWS maintains these runtimes, providing Amazon Linux and Linux 2 environments to run them in. People often compare AWS Lambda to Amazon EC2, so if you're considering either, here's a really quick comparison. Lambda is a fully managed serverless computing service where you only need to upload and run your code to start. EC2 contrasts that by using cloud-based virtual machine architecture. So EC2 will let you control or customize instances, provision capacity, operating system, network tools, and tweak underlying infrastructure to improve aspects such as security. But that is if you have experience handling those types of responsibilities. With EC2, you can migrate existing applications to the cloud more rapidly because you don't have to change the architecture too much. You can instead change the EC2 infrastructure to better support the app. But if you don't have the experience, the budget, or the time to swim in a pool of technical responsibilities, Lambda provides a managed, readily available, and highly scalable and secure serverless computing platform. Now, you won't have access to its infrastructure because AWS handles everything on your behalf. Lambda also only runs in response to a trigger known as an event. It doesn't run 24/7, unlike other platform as a service offerings. On the other hand, that makes it more cost effective because AWS charges you only for the resources that you use. There are many use cases for using AWS Lambda. A short list of those use cases can include taking advantage of serverless computing, executing real-time data processing, perform stream processing in real time, automate daily backups, transform data as it moves through unique resources, use Amazon API gateways to send a request to Lambda via HTTP endpoints, use Lambda's flexibility and cost savings to process clicks in-app. You can use it to process objects you upload into Amazon S3. You can use it for analyzing real-time logs, maintain application performance at any scale, file processing in real time, prepare data for a machine learning model. You can use it in the backend to build applications that are sensitive to latency, also to build web apps that scale up and down seamlessly, even across multiple data centers. You can use it to handle third-party API requests for serverless backend, and also to convert documents into different formats in real time. AWS Lambda is constantly evolving, so you can expect more capabilities coming soon as well. As you can see, there are many benefits of using AWS Lambda. Lambda offers several advantages over other alternative compute services, and here are a few straightforward benefits. First off, Lambda offers high flexibility, availability, and cost savings for building serverless applications. Lambda's pay-per-request pricing model and auto-scaling capabilities ensure that you only pay for the compute resources that you use and nothing more. Second, it has good tooling with SAM, versus code plugins, serverless framework, Pulumi, and many more. Third, you only pay for the resources you use instead of wasting time and money on fixed provisioning. Fourth, Lambda's automatic scalability means you can handle spikes in server activity without sacrificing decent performance. Fifth, it's a fully managed service where you don't have to buy hardware or hire specialists to maintain it for you. Sixth, with server management removed from their to-do lists, your developers are free to improve your code to boost customer experiences. Seventh, Lambda integrates seamlessly with other AWS web services such as S3, Cognito, and DynamoDB. Eighth, it offers programming language options for authoring almost all kinds of applications on serverless infrastructure. But Lambda is not flawless, and it has its limitations. Consider the following scenarios of where not to use AWS Lambda. The first scenario, let's say you need to keep your time-sensitive workloads small to reduce the latency characteristic that happens in serverless computing. Remember, the on-demand nature of serverless computing means that the system shuts down any function that you haven't used in over 15 minutes. The next time you call it, it could take a few milliseconds to several seconds to wake up. It's called a cold start, leading to latency. Different AWS price tiers offer varying wake-up speeds. Another scenario in which you don't want to use Lambda is for long-running workloads, because it runs instances and functions for up to 15 minutes at a time. It limits concurrent function executions to 1,000. All that said, AWS Lambda builds can quickly run through your budget if you're unsure how to optimize those AWS costs. You might be wondering then, what's the best way to monitor and measure those Lambda costs? See, the thing is, many optimization tools on the market today are notoriously over-dependent on tagging. They're also clunky and too complex. They also don't provide actionable insights, such as mapping to specific unit costs, like cost per customer. That makes the results too complicated for many team members to understand or to inform data-driven decisions. Without clear visibility into your Lambda costs, your teams may not know how their work affects everything else, such as your company's ability to price products or services, your overall profitability, or how to work within your engineering budget. Instead, you want a cloud cost intelligence platform that shows you something as insightful and as precise as this. That's a Cloud Zero cost per customer report, which helps organizations see their cloud costs mapped to specific customers. With Cloud Zero, you can also pull other easy-to-digest reports to help you map your AWS costs to specific teams, features, and products. Additionally, our cloud cost intelligence platform will alert you of cost anomalies, so you won't have to realize that you're bleeding cash weeks later. Ultimately, Cloud Zero gives you the cost visibility you need to measure, monitor, and even optimize your AWS Lambda costs. Click the link in the description to schedule a demo today and see how you can control and predict your cloud spend with confidence by using Cloud Zero.